review, it says that there's two parts. Is this time the calculator part, is it all going to be together and not a take home part at the end?
Very good question. The calculated part will be always take home.
Okay.
Don't worry about that. Yeah. Thank you. Thank you for asking. Okay, so my camera looks a little bit weird. I should move a little bit. Okay, I think that's enough. Yeah. And let me turn on the light. Okay, great. So anyone has any question before we start on the exam 2 review? Oh, by the way, Sophia, we do not have a quiz today. Sophia, we do not have a quiz today because we're doing the exam 2 review. Okay. Well, so we have so many questions on the exam 2 review. Instead of me going through everyone, let me ask you. First of all, does anyone has any question about the sections covering and the furniture listed here? No question on this part? Okay. Does anyone has any question about the first page of questions?
Part C, number 3 and 4, or sorry, 3 and 5. I'm just wondering how it got to be 2 pi over 3.
Okay, great question. Okay, thank you for asking. Before we do that, does anyone has any question before the two questions we are going to talk about?
I'd like to go over maybe B or A.
B or A, which one?
I guess B.
Okay, let's do B. Okay, anyone want me to talk about A? Okay, so it seems that nobody requesting for A. Let's start from B. Write the equation of the sine function. This is sinusoidal. This is a very long and fancy word. Just treat it as sine function with the following characteristics. The amplitude is 4. That's why you write 4 here before the sine. The period is 5. That seems to be very tricky. So what kind of coefficients should we put before x in order to get a period equal to 5? Let me write this on paper. So the amplitude is 5. Is 4, sorry. So that's why we put 4 in front of the sine, okay? How about the period? Period is 5. So we want to write something like this, right? Plus, let's say D, okay? So eventually we want to get a function like this. We want to make sure what is A, what is W, what is C, what is D, so that it satisfies all the requirements. The amplitude is 4, so which implies A is 4, period is 5. If period is 5, what can we say about omega? Remember, what is period? Period is always 2 pi over omega. If period is 5, so what is omega? Omega is 2 pi over 5. I think just solve this equation. Okay, any question before we continue? Then you have the phase shift. you are doing 4 pi to the right. If you're doing the right, yes, you do have a minus sign here. That's great. And it is 4 pi to the right. So C is just 4 pi. Okay. What if I ask you 4 pi to the left? Can anyone tell me what if I ask you 4 pi to the left? Pi over 4 to the left, sorry.
Wouldn't it just be is that 2 pi over 5 plus pi over 4?
Yes. Plus. Okay. To the left means plus, to the right means minus for this sign here. Okay. Then you just add this. Okay. Then the vertical shift. So what is the case here? Vertical shift, 3 down. Down means minus here. Apologize. This should be plus or minus, should be plus or minus. Then 3 units down. So this D should be just 3. Okay. That's my explanation for this one. Now you get it. So if you rewrite, you see 4 sine 2 pi over 5 x minus pi 5 then minus 3. That's your final answer. However, for the amplitude, if positive 4 give you the same amplitude, the negative 4 will also give you the same amplitude. So there's a one last thing, plus or minus to the front. Okay. Does anyone has any question how we get this? Okay, Sophia, did you ask me this question?
Yes.
Okay, did I answer your question?
Yeah, you did. Thank you.
Great. Okay, so I think Cody asked me about the third part of part C and the fifth part, right?
Yes.
Thank you, Cody. Third part. Finding the exact value of the expression. So what is the exact value of? Apologize. Second, second minus 2. Okay, as always, whenever you see a inverse trigonometric function, treat it as a angle. Okay, so this guy is always an angle. And we know there is some property about this angle. So what is the property about this angle? Second, this angle, you got a -2. Okay, just rewrite it in the ordinary order. That's it. That's what you get. Then once you get here, still second function looks so complex. I don't know what the second is, but I do know second is just 1 over cosine, right? That's what I do know by the definition of second. Every time you see something complex, you convert something easier, like sine and cosine. Then once you get here, so what is cosine theta? Is -1/2. Just solve this. Move this to this side, this to this side. Okay, anyone has any question how we get this? Well, then you tend to the unit circle for help. Always use the unit circle. 80% of our class for the whole semester is about a unit circle. So cosine theta, -1/2. -1 cosine x is always x coordinate. So the x coordinate for this point is -1/2. So if you draw this triangle, this angle should be, just for the reference angle, should be pi/3, right? Does anyone has any question about the reference angle here? So what is the whole angle? What is theta? The reference angle is pi/3, which is this smaller side. So what is theta? Can anyone tell me the answer? It's on the screen already.
2 pi/3.
Very good. Okay, which is just pi minus pi/3. Okay, which is 2 pi/3. That's it. So here's the thing I want to remind you. Notice that on the unit circle, there are 2 points which use the same x coordinate. However, cosine x is only defined on this side. The inverse cosine is only defined on this side. Okay, and so you can only use the angle here, either on the first quadrant or second quadrant. You cannot use the angle here because that's where it is defined. For the sine, how about the inverse sine? Can anyone tell me where the inverse sine is defined on?
It is defined on the first and fourth quadrant.
Very good. It's pi/2, a negative pi/2 to positive pi/2 on this side. So that's why you can only use the angle on these sides. That's it. Okay. So just to say something extra. Does anyone have any question before we close on this one? Okay, let's continue. Let me adjust the screen a little bit. Sorry, I'm just adjusting the camera. Okay, so it seems that I have to turn off my shared screen so that I can have the whole screen of this writing paper. Okay, so let's do question part 5. What is part 5? Part 5 is inverse cosine -1/2. Okay, again, this seems to be so confusing. However, let me repeat this 3 times. Whenever you see an inverse function, it is an angle. Whenever you see an inverse function, it is an angle. Whenever you see an inverse function, it is an angle. I keep saying this to remind you, okay? This is just angle. Cosine this angle, you get this value, right? But have we already done this question already?
Yeah, it was like it was part of part 3.
Yeah.
Yeah.
Almost the same question. Yeah, then we get the same answer.
Mhm.
So we get here, we just get here from the unit circle. That's it.
Thank you.
Thank you for asking. Okay, anyone has any question on the first page of our exam 2 review? Okay, if nobody has any question on the first page, let's go to the second page. Anyone want me to explain any question on the second page?
Could we go over 4
This
on, yeah, it was
tangent,
yeah,
cosecant.
tangent of cosecant inverse of 5/3.
Okay, cosecant, great. Does anyone want me to go to 1, 2, or 3 before we do 4?
Yeah, could we do 2, please?
My pleasure. So let's do 2. Anyone want me to do question 1? Okay, let's go to question 2. Look, what is question 2? Cosecant inverse secant. How many times I've told you that this is just the angle? Okay, this is the key point. This is just the angle. Remember that. So sine this angle, you get 2/3. So what is this angle is? We still don't know what is this angle. However, we can always draw a fabricated triangle to help us think. So let's say the triangle is this one. Sine theta, 2/3. Or inverse, just to remind you, we are using inverse, so we can only working on the first and the last quadrant. That's where it is defined. That's why I draw a triangle in the first quadrant, because it is positive. The inverse sign is positive, so that it only applies to the positive y coordinates, which is in the first quadrant. Okay, then let's say this theta is the theta we want. This angle is the angle we want. So this side is 2, this side is 3. Right? You just create. Then by the Pythagorean theorem, what is the length of this side? Square root of 5, right? By the Pythagorean theorem. Anyone has any question? We get this angle. I'll get this side. So what is this? This is just cosine theta. Okay, the cosine is a bunch of values, is cosine theta. And theta is using this triangle. So what is cosine theta? Cosine theta is this side divided by the hypotenuse. So it's square root of 5/3. That's it. That's the answer. Anyone has any question on this one?
How come you subtracted for the Pythagorean theorem?
Okay, so the Pythagorean theorem says this side squared plus this side squared gets the hypotenuse squared. Do you agree?
Yeah.
Then you just minus both sides with 2 squared.
Oh, okay.
Okay, cool. Anyone has any question before we continue to the next one? So we just did question 2. What is the next question? We want you guys. Yes.
4.
Part 4. Okay, great. Very, very similar. What is part 4? Tangent cosecant 5/3 blah blah blah. Well, who knows? Again, let me emphasize this again 3 more times. Inverse trigonometric function, you just get an angle theta. Okay, how many times do I need to emphasize this? Just get this angle. Set this to be your angle. Then you can figure out the cosecant of this angle is 5/3. So this is 1 over sine theta equal to 5/3. So sine theta is 3/5. Does anyone has any question how I get this? Okay, now you know this angle. Well, sine theta equal to 3/5. That's a very, very fabulous triangle. 3/5. Do you guys remember this triangle 3/5? So it means that if you can draw a simulated triangle, if this angle is 3, this side is 3, this side is 5, then this side is 4. 3/5, 3/5. Very famous triangle. So once you get to here, this question is just asking you what is tangent theta. Can anyone tell me what is tangent theta?
It's just gonna be 3/4.
Very good. So tangent theta is just 3/4. Just read it from this triangle. Okay. What is the next question you wanted me to explain? Anyone has any question left on the second page?
The first one on the third page.
First one on the third page. Great. Before we do that, does anyone have, we're still on the second page. Does anyone want me to do any question on the second page before we go to the third page? Actually, when I say second page, I mean the third page of the PDF.
Can you go over second question, number E, second question?
Number E, second question. Okay, great. Thank you for asking. Okay, so here is a problem. This is a tricky one. The question, they didn't ask you to do the calculation. They ask you true or false. So true or false? Imagine you are attending a TV show. The host of that TV show will asking you many questions. If you get 10 correct answers in one row, you get $1 million. True or false? This is your first question. True or false? Again, we don't know what this is. What can we do? We turn to our best friend, Unity Circle, for help. We don't know what a bunch of number here. First, we find the triangle or the angle. The angle is somewhere here, right? So what is cosine that value? Cosine is just corresponding to x by coordinate. So it is negative square root of 3/2. That's our cosine value. So this guy is just negative square root of 3/2. Because our reference angle is pi/6. Okay, that's why. And you can just read this triangle, pi/6 here. So this side must be square root of 3/2. And it's on the negative side of the x-axis, so that you have negative. Okay, does anyone has any question how you get the value for this guy? Okay, assuming you know this value already. So what is cosine inverse negative square root of 3/2?
5 pi/6.
Very good. It is actually this this angle here. Why it must be this angle, not this angle? Because again, our inverse cosine is defined on the first and the second quadrant. Okay, quadrant. For other quadrants, it does not work. So this guy can only be 5 pi over 6. Okay. Anyone has any question how we get this guy? Hussein, did I answer your question? Hussein?
Yes, you did. Thank you.
Great. Okay, again, let me emphasize the key point of this question. Inverse cosine is only defined here. So you cannot take an angle here. Instead, you take another angle here, which shares the same x coordinate with it. Okay, we're done with this page. So let's turn to the next page. The first one, what is the restricted domain of one-to-one function? This is page 4 of the PDF. Page 4 of the PDF, okay. What is the restricted domain? So this is just from the textbook. The domain is just here. Remember our tangent defines like this. And here, you cannot take the endpoints. This is just definition of the tangent x, okay? There's no calculation here. This is just definition. If you do not know this, please read all the important definitions of your textbooks. Okay, anyone has any question on the fourth page of the PDF? Fourth page of the PDF.
Do number 2.
Very good. Thank you. Number 2, which part? A, B, C, D. Which one?
A.
Great. Thank you for asking. Graph one period. Now you know this function. Again, the question is very considerate. Before you graphing it, the question asks you a few basic information about the function. What is A? A is just this guy, right? What is the omega? Omega is this guy. So A is 3, which means the amplitude is 3. Omega is 2, which means the period is 2 pi omega, which is 2 pi over 2, which is pi. That's it.
Really quick, Professor. So
Yeah.
when on there, it asks for A and then amplitude. The reason why, so like, let's say if it was -3 sine of 2x, A would be -3, but the amplitude would be 3 because it's always going to be a positive, right?
Very good question. Yes, correct. The amplitude is just the absolute value of A. Whatever A you have, take the absolute value of it.
Okay,
Okay.
perfect. Thank you.
So the period is pi. Then you can draw it. There is no horizontal shift here, no horizontal shift or vertical shift. So you just draw what you like, what you did for sine. But this time, the amplitude is 3. So that's here's 3 -3. Then the period is pi, which is half of the previous one. So you get your pi. Previously, you reach your maximum at pi over 2. Now you reach your maximum at pi over 4. And you reach your 0 previously at pi. Now you reach your 0 at pi over 2. This is 3 pi over 4. This is pi. So going up, going down, going up. That's it. Hi, did I answer your question?
Yeah, you did. Thank you.
Great. Okay, anyone has any question on the fourth page of the PDF?
Could you do F?
I'm sorry, which one?
1F. It's like the first question on the page.
1F? Question 1F? Which page it is on? I'm sorry, which page it is?
It's on the page that we're on right now. It's at the top of the page. It's asking, what is the restricted domain of the one-to-one function?
Oh yeah. So I think I just explained it. So the restricted domain is just negative pi over 2 to pi over 2. It is just a definition. The domain of tangent x. A so-called restricted domain is actually just the domain of this guy where it is 1 to 1. This guy has a domain like everywhere except for x cannot be k pi over 2, right? Except for those parts. It looks like this, very ugly, very squiggly. However, we want it to be 1 to 1, so that's why we only restrict to this part, negative pi over 2 to pi over 2. Okay, that's why we only restrict to this area so that it is 1 to 1. This is a book's definition. Please also read your book's definition. By the way, did I answer your question?
Yeah, sorry, I hadn't seen that you'd solved it earlier.
Oh, no problem, no problem. Thank you for asking. As always, have any question, feel free to ask. Okay, so any question on the fourth page of the PDF? How about the fifth page of the PDF? We're looking at the fifth page of the solution set of exam 2 review.
Could we do D and E?
D and E, great. So what is the D and E ask? Oh, still the same question, graph 1 full period. Well, so D is this guy. Okay, it looks very complex. However, if we don't know how to graph this one, we should be able to graph this one, right? 1 over the sine. So how about we just graph this, then we graph the 1 over effect of it. Again, the period is pi because you have omega equal to 2. So 2 pi over 2 is period is pi. Then everything else will be the same with the sine function. So let's graph it. This is z up, going down, going up. The amplitude is still 1. Nothing strange there. However, the reaches maximum at pi over 4, as we just did for this one. Reach 0 at pi over 2. Reach 3 pi over 4 here, and it reaches pi here. Okay, so now we get those values. But this is just for sine 2x. This is not for cosecant. 1 over it. You guys should remember, whenever we do 1 over it, so if this goes this way, 1 over it, just when x, this value is getting smaller, this value is getting extremely bigger. And with the value is getting smaller, this value is getting extremely bigger. Okay, now on this side, when this value is getting smaller, this value is getting extremely deeper. This value getting extremely deeper. That's it. That's all what you need to draw. Did I answer your question, by the way?
Yes, thank you.
Okay. So a very rough sketch is good enough, but make sure you have those points, they meet with each other. Okay, that's a key grading point. If you meet with each other and you do have shape like this, you get 4 credits. If you meet the shape of this, or if you miss this point and this point, you get a partial points taken off.
And then, sorry,
Yeah.
still related to that one, vertical asymptotes, are there,
Just this,
they're
yeah.
at
Yeah,
pi, right? Yeah,
pi over 2, pi over 2. So
pi over
previously,
2, sorry.
getting pi over 2 is going to 0. However, since we are doing 1 over it, we can never do 1 over 0. It's getting extremely big. Okay?
Mhm.
And Professor, when you said when we have to put the points, you want us to like write it out like coordinates? So it would be like pi over 4 and 1 for that first point.
Well, not necessary. I want to see that 2 lines meet at this point approximately. Just approximately would be good enough. And you have to mark 1 here and mark -1 here. I think that's a very basic requirement. And make sure you have pi over 4 here. And those where it goes 0, where it is going to the deepest point, and where it goes to 0 again. Okay?
Okay, thank you.
Okay. So how about the part E of that question? What is part E? Is y equal to cotangent 2x? Cotangent 2x. What is cotangent 2x? Cotangent function is so complex. Still, I don't like cotangent function. So what can we do? We don't know cotangent, but we know tangent, right? Everybody knows cotangent, right? Here's tangent 2x, which means the amplitude is half of that. So, the period is half of that. Previously, tangent function has a period pi. Now, since we have the omega before x, the period is pi over 2. So let's draw tangent first. This is your approximation of the tangent 2x, just in one period. Do you guys agree?
Yes, and that's just because it's normal its normal interval is pi, correct?
Yes, very good. So if you draw one more period, it should look like this. Very ugly. My sketch is very ugly, but it roughly looks like this Wiegenich curve, right? Okay. Now see what you get. You are 1 over it. 1 over it. So previously when you go to 0, you go to infinity. Previously you go to infinity, now you go to 0. Okay. Now, okay. Apologize. This is my sketch is so opposite of the beautiful sketch. Let me draw it again. The idea is right, but my picture is so ugly. So that I want to draw it again. So now you should be able to see something like this. A new curve should look like this. Okay, with period from 0 to pi over 2. Just for this. This is tangent to x. This is cotangent to x. Just this line. Okay, anyone has any question? Make sure it goes to this pi over 4 point. And it's approximating the infinity on this side. It's approximating the negative infinity on the pi over 2 ends. Okay, anyone has any question about this sketch? It's just a rough sketch. When I grade your papers, I'm only looking for rough sketch. So I would accept the sketches like this as long as you mark the points. Okay. Okay, we are done with this. Are we done with this page? Page 5 of the PDF. Does anyone have any question more? Page 5. How about page 6? Page 6 of the solution key.
Could we go over the first one on the 6th page? I guess it's B.
Great. Let's do the first one. Well, the function is y equal to 4 sine pi x plus 1 plus 3. So you just read from function and you recognize this is a, this is omega, this is means shift left by 1 unit, plus 1 means shift left, plus 3 means shift up 3 units, okay, so we get all the information to answer our question. So this guy is omega is pi, which implies period is 2 pi over pi, which is 2. Okay, so we answer all the questions before we draw the graph. Oh yeah, by the way, this 4 is positive, so there is no reflection. 4 is positive, so no reflection. So when you draw the graph, shifting left by 1 unit. So if we don't shift, what would happen? The period is 2. You get a 0 here, but you shift up 3 units and shift left by 1 unit. So now you get your
I was like, that's like the new origin, right?
new origin here.
Okay, okay.
Then remember the amplitude is another 4, so origin is here, so you go up to this 4 plus 3 is 7. Then you can go down from here 4 units, get -1. Okay, and your period is 2. So here is -1. When you finish a quarter of your period, you reach the maximum. So in other words, remember the sine graph looks like this. When you finish a quarter of your period, you reach your maximum. You do another quarter, you get your 0. And you do another quarter, you get your lowest point. So period is 2. So when you start from here, you travel half unit, you reach your maximum, which is here. Then you travel a quarter, which quarter over 2, which is also 1/2. You get to here. Now you go to here, another quarter of the period, you reach your minimum, which is -1 here. Then you go another quarter, you go back to the origin, which is this line. So this is one period of it. Oh yeah, the question asks us to shoot 2 periods. So we just repeat the same thing. Then you go a quarter of the period, which is 1/2. You reach your maximum. Then you go 1 unit more. You reach your origin. Then you go to another half period. So you go to the minimum point. Then another period. When you get to another quarter period, when you go to 3, you complete the second period. Okay, so let's see how many points I have marked already. I marked 1, 2, 3, 4. The question wanted us to mark at least 5. So let's mark this one. This guy is -1/2. I don't have enough space here. And it's 7. Let's also mark this one. This is 5/2. Apologize, this is 5/2. And you reach the bottom. Okay, so that's it for this question. Again, my sketch is kind of acne, but I hope you get the idea.
Can you scroll your paper up a little bit?
Okay,
Thank you.
thank you for asking. Okay, anyone has any question before we continue?
So because it was a period of 2 that made its first cycle go from -1 to 1.
Yes.
Okay, just making sure. I got confused and started drawing it where it ended at 2, but that was wrong.
This should be 1.
Yeah, yeah. Okay, thank you.
Thank you. So let me re-emphasize this. First, make sure you know where the origin is. Second, then you draw the corresponding points according to the amplitude and period. Then third, you just extend the fourth period. Okay, this is a general step. Know other origins, then know where the amplitude and period is, then where it reaches maximum, we go back to 0 again, go to the minimum point again, go back to 0 again. So now you have a good sense of it. Okay, follow those steps. Okay, anyone has any question before we continue? Okay, any more question on this 6th page of the PDF? Well, 7th page on the PDF. Anyone has any question?
Yeah, could we go over the second one, please?
So, you mean the 5th one? 5th question?
I think it's 7, or is it 7? Oh yeah, 5, sorry. I was on the wrong one, my bad. Yeah, 5.
Question 5, which part, A or B or?
B. Yeah, B.
B. Cool. Okay, question 5 is different. Now you are giving me the graph. You want to know what is the function is. Okay, so first of all, let's just look at the graph. Let me ask you a few basic questions. What is the amplitude? Right here. What is the amplitude? Just reading from the graph. Can anyone answer my question?
It's 1.
Very good. Amplitude is 1. So amplitude is just absolute value of A. Right? So A can be +1 or it can be -1. Okay, this is still to be determined. We will leave that later. So what is the period of the graph? Just look at it. Read it. How much length does it take to finish one period? Okay, so reading the graph may be hard. Let's do some basic algebra. When did the graph reach its minimum?
-1.
No. The x-coordinate when it reaches minimum. X-coordinate.
5/6.
Yes. Do you have other points which has this minimum?
7π/6.
Very good. Okay. So it reaches minimum here and here. So from here to here, it completes one period. So in other words, period equal to next second point minus the first point, which is pi. Okay. Okay. So we figure out a period. So let's figure out the vertical shift. Do we have vertical shift? Just look at the graph. Does the graph look seems to be moved up or moved down? No. I'm sorry. What is the question?
No, this is for, was it 5 in?
5B.
Oh, okay, no.
5B. This is for question 5B.
Is it just shift? Yeah, just vertical. It's a drop? No, it isn't, right? Because it begins right there. Right past 0, right?
Well, the central line is still in the 0. So the graph has not been shifted up or down. So there's no vertical shift. Okay. But look at the graph again. Definitely we have a horizontal shift. Okay. So originally we achieve y equal to 0. Oh no. So the answer key use cosine. So let's just use the cosine. Originally, when x is 0, y is 1, right? For y equal to cosine function. However, look at this case. So what's our new x equal to what? Y is 1 for our new function on the graph. Just read it from graph.
Is that negative, or pi over 6 is equal to, it's negative though, right? Because it's being reflected.
Well, you're kind of right. Yeah, but I do not want to mention the point on the answer key, because the answer key did not clearly indicate the negative pi over 6 point. So let's use another point where it clearly indicated x is 2 pi over 3. Okay, this point you can read from the graph clearly, right?
Yes.
So when x is pi over 3. So how about we call it shift right so many units. Okay, we call it shift right so many units. Okay, now you get all the parts. Amplitude, period, vertical shift, and horizontal shift. So we want to create something related with cosine. Notice that the equation is not unique. We have different solutions. Here, I'm creating a solution which is different from the solution key. The amplitude can be 1, can be negative 1. Let's just make it easy. Just make it 1 here. Okay, positive 1 here. Cosine x. Then the period is 2. A period is pi. So which means omega is 2 pi over pi. Just 2. Which is 2 here. Then x. Then no vertical shift, only horizontal shift. Horizontal shift right, so many units. Shift right. Shift right means subtract. Okay, always processes including the shift part, x minus. Then processes. That's it. If you want to get rid of this 1, you just don't write it. That's it for a solution. I mean, I know this looks different from what the answer key is giving, but they are exactly the same answer because they produce exactly the same graph. If you just follow the steps, know what is A, then what is omega, what is vertical shift, what is horizontal shift, you can just literally create the cosine function in this way. Okay, so anyone has any question on this one? Hi, Sabrine. The exam will be held during next Tuesday's class. During next Tuesday's class in Zoom. Just like what we did for exam one. We are going to have exam on Zoom. Okay, thank you for asking. Okay, so for the 7th page of exam 2 review, anyone has any more question?
Do number 6.
Okay. Write the trigonometric function as algebraic expression in U. Show all work and diagrams to yield your final answer. Well, what does that mean? I never see this kind of question before. Write the algebraic expression in U. Okay. So don't worry about it. U, if you don't know, just don't worry about it. Again, whenever you see an inverse trigonometric function, this is just your theta, okay? Just follow the steps. Then you create a fabricated triangle. Okay, so if this cosine theta is U, it means U on this side, unit circle on this side. Do you guys get to this? Just create any triangle. If this side is U, this side is 1, this side is just U. So that is the cosine theta is just U over 1, which is U. So how about this side? This side by the Pythagorean theorem is 1 minus U squared, square root of it. Okay, does anyone have any question on this part? Again, as we did many times before, this is just tangent theta. And you know the theta is in such a triangle. So tangent theta is just this guy divided by this guy. That's it. Any question on this one? Okay, so let's go to the next page. Page 8 of the exam 2 review. Anyone has any question?
Can we do E?
E. Before we do E, does anyone have any question about the previous ABCD part? Okay, let's do E. Well, 2 cosine theta plus cosine theta minus 1 equal to 0. Again, this one looks very, very complex. We don't know what is cosine theta is. So how about we just set cosine theta to be y? So you need to solve such a quadratic equation. You can factor it. This is college algebra material. So you get 2y minus y plus 1 equal to 0. So we just factor it. Then you can derive 2y minus 1 equal to 0. Y is 1/2, or y plus 1 equal to 0. Y is negative 1. So once you get those y values, go back, change your y to be cosine theta. Cosine theta is 1/2. For the first one, cosine theta is 1/2. So what is theta? We see this angle many, many times. Cosine theta is 1/2. So what is theta? You can just,
Pi.
no. Cosine theta is 1/2. We're looking for this angle. What is the angle is?
2.
60.
Very good. Pi over 3 or 60, whatever you like. Okay, that's our first value. Then we're looking for the second value. Cosine theta is -1. So this might be confusing. So again, we turn it to the unit circle for help. It's -1 here. So what is this angle?
So is that 3 pi over 2?
What is this angle? Just this angle with the terminal point here.
Is it 270?
Oh, I apologize. So -1 is on this side, on the x-axis, because we are doing cosine theta. I apologize. So what is this angle? Apologize.
Is it pi?
Very good, pi. Okay, that's your final solution. Pi over 3 or pi. So did I write everything correctly? Oh yeah, the solution key has an issue. It did not including pi. Solution key has such an issue, by the way, just let you know. So you got those values. And I think the solution key also made a mistake. The solution key including 5 pi over 3. So where is cosine, inverse cosine defined? Let me ask you this question. Where is the inverse cosine defined? It is on this here, right?
It's on the top side of, yeah, quadrant 1 and 2.
Yeah, so it can only be this pi over 3 or this pi. The solution key made a mistake to write 5 pi over 3. So I don't think that's a good angle to write. Okay, the solution key made a mistake. The correct answer is what I write down here. By the way, I'm not the one who making this solution key or making this exam. Okay, anyone has any question on this page?
F2.
Well, F, great. Well, for question F, you are using almost the same technique, but this time you see a secant, and you see a tangent. Equal to 1. So what is secant or tangent here? You don't want to see two trigonometric functions. You want to convert them into one. So secant, very complex. It is cosine over sine, right? I apologize, not cosine over sine. It's 1 over cosine squared theta plus tangent theta equal to 1, right? Then you can move this 1 to this side. So 1 over cosine squared minus 1 equal to negative tangent theta. So 1 minus cosine squared theta, you combine the two fractions equal to tangent theta. So this guy, sine squared over cosine squared equal to negative tangent squared theta. This is just tangent square theta equal to negative tangent square theta. Now we successfully get rid of all of the sine and cosine. So again, we want to solve this tangent theta. How about we treat it as y? So y squared equal to negative y. If you move every y to one side, you get a y factor y. This y equal either 0 or negative 1. Okay, so this process is long. Then you figure out your tangent theta is either 0 or negative 1. So when the tangent theta is 0, what do you get? When tangent theta is 0, what do you get? What is due for theta? Theta is 0, right?
Yes.
Very good. So when tangent theta is negative 1, what is all? Theta.
Is it just pi?
No.
One.
So think about the graph we make. Here is pi over 2. Here's pi over 2.
Zero.
When tangent theta is negative 1, so theta is negative pi over 4. Okay? So that's the two solutions. Again, I think the solution key made some mistakes. So this is the correct solution. Let me summarize the key steps. First, we try to get rid of this second by combining it with the 1 so that you have something like tangent theta. Then you treat tangent theta as a y, then factor. Then once you get y values, you get the theta corresponding to it. Wow. Anyone has any question on this one? Wow, that's so much work. Oh yeah, we are almost reaching the end of this class. I don't think we have enough time for another question. So, okay, do not leave the Zoom session. Do not leave. I need to take the attendance. So I'm thinking, since we didn't finish this exam 2 review, I'm thinking about organizing another Zoom session sometime recently. Okay, so how about this? We meet again on Sunday evening, 8 p.m.
Yes.
Does that work for you guys?